My name is Mark Sales. I am a solutions architect at AWS, and I work in an area of the platform which is mostly catering towards developers. So I work with a lot of the serverless services, so things like Lambda, API Gateway, Event Bridge, some of the queuing technologies, if you're familiar with the platform. And I've been programming in Java for nearly 20 years, which makes me feel pretty old. It was the language that I most enjoyed using at university. I learned C and Python and Java, and Java was just really the one that I enjoyed programming in. So I've just been programming in Java all my career, and it's done me really well. So I've continued to focus in that area. And if you were in the Lambda space, you may have heard of an open source project that AWS created called Lambda Power Tools, and I'm one of the co-creators for that project. So if this interests you and you want to dive even deeper, then Lambda Power Tools is something to look into. But for today, we're going to be talking about cloud native architectures, which I find really interesting. It's what got me most excited about AWS when I was a customer. We're going to talk a little bit about what architectural benefits you get for free, how best to get started, and then what are the trade-offs, because everyone in technology knows that with a benefit probably comes some sort of trade-off. So understanding the trade-offs is the real key, in my opinion, to being successful in technology. And then if you're working in the Java space, you may have heard of GraalVM, or you may be trying GraalVM. I'm going to be talking quite a lot about GraalVM native image. And one of the frameworks that I think is really awesome in that space is Micronaut. And full disclosure, I'm on the Micronaut board, so I'm definitely biased. Quarkus is also an amazing framework, and Spring is making some real improvements in this kind of GraalVM space as well. So lots of cool technology coming out. And as a solutions architect at AWS, I have quite a lot of talks with customers who are planning to use AWS as a platform, and they kind of fall into two types of camps. Either it's the camp of people who are wanting to migrate existing applications to AWS, or a company wants to try something new and is doing a proof of concept, and they're trying something completely new and a new way of working, and they want to understand how they would do that on AWS and how they would use familiar technologies or new technologies to accomplish their business goals. Okay, so this talk today is about the starting from scratch side and what is exciting about that way of working and what benefits that it can bring to you. So our CEO is a guy called Andy Jassy, and his famous quote, or one of his famous quotes, is that there's no compression algorithm for experience. And I quite like that. I definitely learned a lot along the way. I can definitely think of all of the problems that my software has caused over my career, and I wouldn't make the same mistakes again. So I feel like Andy's quote is pretty good, because there's just so much to understand and learn, and building software now, I feel like we as developers get stretched wider and wider to think of more and more different things. So security, high availability, scalability, fault tolerance, how are we going to do metrics and logging? How are we going to keep our system from being expensive or more expensive than the business value? How can we think about portability, and how can we think about our carbon footprint of the system, which is something that we're becoming more and more focused on. So there's just so much to think about as a developer. But I think there's some pretty attractive technology out there in the cloud space that really helps with this. So my old boss is a lady called Rory Richardson, and she said that serverless is the compression algorithm for experience. And maybe today I'll explain some of that, and maybe you disagree or agree. And yeah, I'd love to hear your comments and questions, and I'll hope to answer as many as I can. So in particular, today we're going to be talking, or I'm going to be talking about AWS Lambda, which is a function as a service style service that AWS has. So you upload your application code to Lambda, and Lambda will execute that code on a number of different triggers. And that trigger could be a HTTP request, or a trigger from a messaging queue, or any number of different integration points. And we have a lot of native integration points with native AWS services, but also with self-managed solutions, things like Kafka and ActiveMQ, RabbitMQ, things like that. So Lambda is super flexible, and I think it really adds some really key architectural best practices in its design. So I think you get a lot for free by using Lambda. So I'm going to talk through some of those benefits and see if I can excite you about trying something new. So firstly, AWS Lambda is a really high security platform. So maybe people have perceptions that it's for small workloads or for DevOps tasks or admin tasks. But this is a very high security platform. We have very, very high levels of isolation. AWS Lambda is a multi-tenanted solution, so we have lots of customers obviously using the same service. So we have to make sure that all of our service is completely isolated from all the other customers that use the service. And we do that with the strongest possible isolation levels. So we don't run two different customers' code on the same container. We actually use virtual machine isolation levels. So in this diagram, you'll see that we have a bare metal server in our data centers. And on those bare metal servers, we actually run full micro VMs. And this is a technology called Firecracker that we've produced internally and open sourced. So you can go check that out on the GitHub page. And then within these micro VMs, we'll place your code and we'll execute your code. So two customers will never share the same virtual machine. So if security is interesting, I think the availability and the fault tolerance is also amazing. So if you're using AWS, you have the ability to use different availability zones. And an availability zone is a highly available set of geographically located data centers. So availability 1 is a set of data centers or a data center. Availability zone 2 is a completely separate location, which is separated by a physical distance, so that one power outage or one natural event doesn't affect another. And then typically AWS regions have 3 availability zones. So you have a very, very high level of fault tolerance. And this is actually pretty difficult to do. I used to be a customer, and I used to have an application that ran in a data center, and actually having a second data center where all my data was replicated across, and we had failover scripts. If anything was happening with the data center that we needed to enact a data disaster recovery process, it was really difficult. Now with AWS Lambda, you don't even really see that the code is actually running in 3 different, or potentially 3 different locations. All of that is managed by AWS. So you upload your code, and it is automatically scaled across all 3 availability zones whenever more traffic comes to your system. All of that scaling just happens automatically. And if there is an issue with one of the availability zones, you as a customer don't actually have to do anything. We will automatically move traffic away from that availability zone and continue to serve your traffic on the other availability zones. So all of that fault tolerance and rebalancing and load balancing is all part of the service, which is really cool. And then a question that I get quite a lot with startups and scale up customers is we don't really know what our expected traffic is going to be. So how do we plan for capacity? Well, that's a real strength of AWS Lambda as well, because we will just keep spinning up extra environments for you every time that you need one. So if an extra peak of traffic comes into the system, we will keep scaling up your function to handle that traffic. There will never be a period where there's too many requests and it's busy scaling up and not able to take the traffic. Okay, so with a new account from AWS today, you could scale up to 3,000 virtual machines in a minute. Okay, that's a huge amount of scaling just from a default setting, and that's there to protect you as a customer, so that if you create some sort of infinite loop, you're not incurring a large cost. But also these are what we call soft limits. So if your application actually needs more capacity than that, then that's absolutely fine. You raise a ticket to the support team, and they're very used to raising these limits. So we have customers using hundreds of thousands of concurrent virtual machines. Okay, so let's move on to observability. So observability is, I don't know, maybe it's an afterthought, or we've built our application, so now we need to tie it into the corporate logging system or the corporate metric system. AWS Lambda, everything that you produce from your application that goes to standard out automatically gets taken to a service called CloudWatch. So CloudWatch Logs is a centralized logging solution, which is used by a number of AWS services. So metrics and logs that are produced by the Lambda service itself, you'll see in CloudWatch Logs. But this is a really neat way of not having to do that extra work of producing a centralized logging solution. Your application just writes logs as normal to standard out, and they just get automatically shipped in near real time to CloudWatch Logs, and they're stored there for as long as you want. If you want to have a short retention period because this is a dev area, that's fine. If you want to keep them for a long time because this is a production system, that's also fine. And there's lots of tools within CloudWatch that will let you will query your logs using SQL-like functionality. So you can say, I had a request with request ID 123, show me all of the logs associated with the request ID 123. I think that's really cool. It just saves you so much time. And the same with traces. So if you're producing trace graphs of your application, maybe you've got an application which is triggered by a web request, and then you have some business logic in a Lambda function, and then that writes to a database. You can enable tracing at the front end and in the Lambda function, and it will produce you a trace of the execution. So you'll see how much time is spent in the front end, in the middle, and you'll get a really pretty graph to show you, maybe your code's too slow or maybe your code's perfectly fine. I like to debug my code by looking at where the execution time is, and is that where I expected the majority of the time to be. I think that's a really nice way of thinking about systems. So scaling, security, observability. Portability, I think, is also a concern for people. So people think of AWS Lambda as this AWS service, and you have to be writing very specific code for it to work. And that's just, I don't really think is the case. I think as Java programmers, we've always built with interfaces in mind and hexagonal architectures and testing. And I think as Java programmers, we're actually really able to benefit from the programming model that Lambda brings. So this is actually some code of a Lambda function of mine. So I actually scrape data from a Nexus repository regularly, because I want to see how well one of my open source projects is doing. So I've got a Lambda function, and this is a Lambda function. So this is a Java object which implements an interface called a request handler. And there's two attributes there. One is a scheduled event and one is a string. And a scheduled event is the object that is triggering my Lambda function. And you'll see that in the handle request. And every time I schedule an event for this Lambda to function, to run, it will execute that handle request method. So in this case, I'm going to a secrets provider, grabbing a secrets password for a website, logging into the website, retrieving some information, and then saving it to a repository. Is this code portable? I would say it's pretty portable. So I've got a couple of imports to AWS objects, but really there's nothing particularly special about this class. It's pretty plain old boring Java. There's no annotations, there's no dependency injection. You can of course do that, but this is super boring plain old Java. So I would say this is pretty portable. If you are used to using application frameworks, then Micronaut, this is a Micronaut controller. This is also a Lambda function. So Micronaut has written their framework in a way that they will take the event which has been used to invoke a Lambda function, in this case a web request, and they'll map that web request to a method. So in this case, if you have a GET request to an API, it will trigger the index method, and it will return, in this case, a JSON payload with an attribute message and a value hello world. Okay, so this is definitely super portable. This is probably code that you'd expect to be running on a VM or on a container. But the way the framework works, it does this adaptation from a Lambda function way of working to a kind of a regular web container or web controller style of programming. So Lambda kind of sounds interesting. It's got some benefits, but what are the trade-offs? Okay, so there definitely are trade-offs, and you should definitely be considering whether or not Lambda is suitable for your workload. And at the end of the presentation, I've got my Twitter address and my email address. And if you ever want to, have a more in-depth conversation about something you're thinking about, feel free to drop me a message and some questions. The trade-offs in particular for Java and Lambda is that the concurrency model, where one request that comes into a Lambda function equals one virtual machine. And if you have another request at the same time, then another virtual machine will be created. And that will continue where you have an amount of concurrency. So if you have 10 concurrent requests, there will be 10 virtual machines to handle that workload. And these virtual machines, load up very, very quickly within a second. So it's not like booting up a server or a traditional container. These micro VMs boot up very quickly, but each micro VM will have a JVM, which holds your application code. And the more code that you load into the JVM, the more time it takes to start up. And that's just the style of programming that we're used to working with Java. But that means that each JVM also has a just-in-time compilation characteristic. So typically when you work with Java, there's a period of time where it's learning about the application and finding hotspots in the application, and then those hotspots are compiled, really well, and you achieve, fantastic performance. So the trade-off with Lambda is that you get more virtual machines, more JVMs, and more periods where the just-in-time compiler is working hard to optimize your code. So that is a bit of a problem, but there's a really interesting piece of technology that is also looking to address this space. Java startup speeds are not just a concern for Lambda, but for other function as a service services, but also for containers who want to have a very appropriate amount of capacity to what's coming in. Ideally, if you have a container platform, you should be able to step your capacity up and down as the traffic profile changes. So all of the benefits that we can do to Java to make it scale faster for Lambda actually also benefit, if you have a container workload. So if you have a highly optimized container workload, you're probably going to do well on Lambda. And if for whatever reason you've tried something on Lambda and it doesn't work, you're probably setting yourself up quite well to run on a container platform. So the technology in case is GraalVM. In particular, when I say GraalVM, I actually mean GraalVM native image. And GraalVM is an open source project which is mainly sponsored by Oracle, but also has more and more input from Red Hat. And native image is a tool which takes your Java code and compiles it to a standalone binary executable. So instead of having bytecode that runs in the JVM, everything that is required to run your Java application has been pulled together and put into a binary executable. So everything from garbage collectors to your dependencies to your own code is collected and packaged in one native binary. And then the interesting thing about native image is that it will do all of the optimizations during the build phase. So unlike the JVM, which has this warm-up phase, GraalVM native image does all of its optimizations ahead of time. So you get a very flat performance profile. So it's really interesting for Lambda workloads. And because it is a native binary, it is specific to an operating system and the CPU architecture. So if you're producing native images for Lambda, Lambda uses a Linux operating system, and then you can pick from either an x86 architecture or an ARM architecture, and your native image binary needs to be produced for the deployment that you want. So how does this work? How do you turn Java code into a binary? Well, way beyond my capabilities. There's some very clever people at Oracle producing some really cool products. What happens is that you take your application and you use a build plugin for either Maven or Gradle, and it does a reachability analysis of your code. So you give it your main class, and then it basically does like a giant scan of all of the classes, methods, and attributes that can be reached by your main method, and collects all sorts of data about that and tries to understand where to optimize your code. And anything that isn't touched in that analysis. So any packages or dependencies that aren't used, it ignores and it purposefully leaves behind. So if you had to bring the whole JDK, that's 350 megabytes, and we wouldn't want to load that all into memory. So native image does an analysis of your code, looks at what classes, methods, and attributes aren't used by your application, and then drops that all on the floor, and then produces just a single binary of everything that is required. I find that pretty amazing as a technology idea. I think that's really cool. So a Lambda function, even without a JVM, is about 20 megabytes. And that's everything that the application needs to run, to garbage collect, and to do everything else that a Java application might do. You also no longer need to install a Java runtime. So, you don't need Java 11 on the machine. You can just use the binary, and that has everything it needs. So again, I don't want to give you the pros without the cons. I don't think that's a good idea. Native image, because there's all this pre-optimization and removing anything that it doesn't require, means it loads a lot less code. So startup times are really fast. You don't have the same sort of Java load times that you may have had before. It also drastically reduces the amount of memory that you use. And Lambda has two axes for its price component. One is how much memory you use, and the second is how long your Lambda function runs for. So if you can use less memory and run for a shorter period of time, you're drastically reducing the amount that you're paying for your Lambda. But the cons, well, it's doing all of this analysis ahead of time, and it's doing all of this optimization ahead of time. So build times are longer than normal Java build times. So if I have a small application that maybe takes 10, 20 seconds to build with Maven, it's probably going to take 2.5 minutes to build with GraalVM. And we have to go back into the old days of compiling something for a particular operating system and CPU architecture. Java is fantastic, it's super portable, but in this case, to take the benefits, we have to also compile to a specific architecture. And then the biggest con for me is that to do this analysis, it has to assume that the application is not very dynamic. And it has to take what's called a closed world analysis, a closed world view of your application. So that isn't Java. Java is a very dynamic language, and it uses things like reflection to load things at runtime. Well, GraalVM native image doesn't allow that sort of functionality. So if your application has that sort of functionality, you need to tell it that actually this class is going to reflectively load this resource, and you need to tell native image that at build time, which is a very strange concept. It took me a long time to get my head around that. So, if I'm using the Jackson JSON parser, those classes are reflectively loaded. So I need to tell native image that my domain objects are going to be reflectively loaded. But the benefits that native image brings are fantastic. Your applications start in hundreds of milliseconds instead of seconds, which means that you can produce applications with very low latency and highly responsive to a customer, which I think is fantastic. So this is where I was going to do a demo at the event, and I think I'm going to try not to risk the demo gods, and I'll actually just talk you through some things instead. But the slides have been sent to the organizers, so hopefully they'll pass them on to everyone who wants them. They've included some code that you can try on your own. So if you're getting started with AWS Lambda and GraalVM and native image, it's quite a lot of new technologies to think about. And the way that I would advise customers who are trying this is I would go on to the Micronaut launch website. This is an amazing website. Whoever made this is way beyond anything I could ever make. So you click around on the website, you choose what type of application that you want, and you choose your Java version. And then you can, very interestingly, add features. So at the bottom, there's a big black button called Features. And I can say how I want to tailor my application, and it will build me a template application with those features. So I can say I want a Lambda function, which is triggered by a HTTP request. And I want all of the Micronaut built-in support for GraalVM. So all the build tooling and Docker support to really make GraalVM a lot easier to use if you're unfamiliar with the technology. And then also in the middle is a feature called AWS CDK. And CDK stands for Cloud Development Kit. So we're going to produce an application using this website. We click all the features that we want. Then in the bottom right-hand corner, there's a Generate Project button. So you can just download an artifact, a zip file, which includes all of the application code, or it will tell you the command line arguments that you need to run to build this project using the command line Micronaut app, or it will give you a curl command to run. So it's very, very flexible. And not only will it give you the application code, but if you include the AWS CDK feature, it will give you all of the infrastructure as code as well. So you'll get a multi-moduled Maven or Gradle project. Half of it will be your application code and half of it will be your infrastructure as code. And I don't know if you're all familiar with infrastructure as code. Often it's expressed as YAML files or some sort of property format. AWS CDK takes a different approach. If you've heard of Pulumi, I guess it's similar to Pulumi. Your infrastructure as code is actually Java code. So you can use your IDE to do tab completion, documentation scanning, unit testing, whatever you like about programming in Java. But even more so than that, you could produce, your corporate standard API as code, and then save that into your corporate Maven repository and share it with another team, so that when they're producing an API, they can take your code, your Java code, and run with it. And this Java code is used with CDK to produce your resources on the AWS cloud. So I think it's a super easy way of representing what you want to be produced in AWS with a familiar programming paradigm. So, I can specify where I want the code to be loaded from. The code is going to be loaded from my Micronaut resource path. I want a Lambda function with a certain memory size, and I want it to produce traces. And that's all handled by the Micronaut launch website. It has a really tight integration with this functionality. So it's very easy to not only build an application, but then to deploy it to the cloud as well. So these are a couple of examples I would recommend trying if you're interested in getting started with Lambda and Micronaut. So you can run the curl command on your machine, and it will actually call the same API that the website is using. It'll specify the features, and a zip file will be downloaded to your machine, and it will include the two projects that I mentioned before. So I've included a couple of different application styles. but also an application that will be triggered every minute. So if you had some admin tasks that needed to happen on a schedule, this is a style of Micronaut application that can be triggered on a cron job, for example. And this includes the application code and all of the infrastructure code that is required to deploy it to AWS. So hopefully that has kind of teased something new and giving you an idea of what's possible and some of the benefits that AWS Lambda can bring. And yeah, please reach out to me if there's anything I can do to answer any questions or any ideas that you have. You know, if you have an idea for a potential new project, I'm all ears and happy to help at any time.